far as we need, and they're going to need the end. All right, arsenic. How many protons, Andy?
Come back to me.
Okay. Angela, how many protons in arsenic? 33. Kayla, how many electrons in arsenic? And how many neutrons, Brandon? 45. Issues with that one, Andy, or are you okay? Because I forgot you weren't here when we did this on Friday.
I get it. I just need to get used to it.
Okay, that's fine. All right. We okay on that? All right. Number 3 there, the iron. How many protons, Isabel? Yeah, with the Fe. The third one in that set. 26. How many electrons do we have in A?
26.
Okay. What does that plus 3 mean up there? You remember what we did with that when we had that on Friday? Say what?
I left early Friday.
Oh, that's right. So did you watch the YouTube video to see what to do with it?
Yep.
Okay. So, you know the protons are 26, and we know the electrons are 26, right? All right. When it says plus 3, that means that you lost 3 electrons. All right. So if you lost 3 electrons, what are we going to do to that number? You know, minus 3. So how many electrons are we going to be left with? 23. Okay. It doesn't affect the protons, so it's not going to affect the 26. And when it's not going to affect the neutrons, so we're still going to do what to find the neutrons? We're still going to subtract. So we're still going to say 55 minus 26, which is what? What? 29. Okay. Does that help? So if this number had a minus sign on it, that would mean what? You would add the electrons. Okay. Does that help with what you saw?
Yeah.
Okay. So what's the mass and the charge on a neutron? What's the mass on a neutron, Eiley? You're what? Yes. And what's the charge?
0.
It is 0. All right. Now, hyphen and nuclear notation. So if I want to write hyphen and nuclear notation, I need to know their masses and their numbers, right? So what tells me the atomic number here, Sheena? The electrons. So I know my 50 protons, so I know my atomic number is 50, right? So that tells me the element. So what element am I? 10. So Tin and Sn. All right, so if I know that, what do I put at the end of the 10? The mass or the number? The mass. So how do I find the mass? What do I do there, Passion? Add what together? Protons and neutrons. So my protons are 50 and my neutrons are 70. So I get a mass of 120. So everybody okay with what Passion said about protons plus neutrons? To get mass? Yes? All right, so she said that goes behind the hyphen. So that is hyphen notation right there. Everybody good with hyphen notation? Now, to do nuclear symbol, we use both numbers. What number goes at the top? The mass. So 120 goes at the top. And what number goes at the bottom? The protons, or the atomic number, which is the 50. Everybody okay with that one? Yes. Now, I put something in the homework that we didn't actually do in class on Friday. Okay? So, most of you are probably fine with it, but let me just run through one real quick. So, let's say that I gave you, that's not what I meant to do. Let's say that I gave you 28 protons and 24 electrons, and let's just say that I gave you 30 neutrons. And I asked you to write this in nuclear symbol notation. All right? Okay? So what element would we have if you were going to write that in nuclear symbol notation? What element do we have? Nickel. All right? We know we have 28 protons.
So you always go off the protons, right?
You always go off the protons, yes. So you have nickel. And again, what did Passion say to find the atomic mass? I have the protons and the neutrons, so the 28 plus the 30 will give us what? 58. So we're going to put 58 here for the mass. That doesn't change. What do we put for the atomic number? 28. Now, those things we all did Friday. The only piece we didn't talk about Friday is, what can you tell me about the protons and the neutrons, or protons and electrons right here? They're not the same, right? That tells us that this is an ion. So when I write this notation, I have to put what right here? A charge, right? Now, some of you already yelled out the right answer. So what charge goes there? Well, what's the difference between the protons and the electrons? Okay, we've got a difference of 4. Now, what do you have more of? More protons or more electrons? More protons, so you put a positive there because you have more protons. You have a greater positive charge than you do negative charge. Was everybody okay with doing that in your homework over the weekend? I mean, not over the weekend, last night. Keep thinking because I wasn't here yesterday. It was over the weekend. Yes?
Couldn't you just think of it like opposite?
You can. However you want to think of it is fine. Anybody else? Question on that? All right. Can we talk about the homework while we're doing this? And then we'll do the test after we go over the homework. Yes? Okay.
Which one did you say was required? I did both. but-
You had to do both. Yeah, I only gave you that option on Thursday.
I thought you were doing all this every night.
Yeah, no, I was talking about homework from last Thursday night because he was out Friday and I checked homework. So I was trying to get his 0 that he has in the grade book taken care of. You weren't here, so you got a 0. That's not on blast. It's not like I told him what your test grade was. That would be on blast. Your test grade was pretty good, though. You might want that one on blast. I mean, if I made that, I certainly want it on
He
blast.
got them in 6.
He's one of the 2 in here who did. The other person's pretty shy, though. She might not want hers on blast. All right. Now, y'all only did the odd numbers, right?
Yes.
So just check what you did. If you did more than the odds, check the parts you did. Don't fill in all the other stuff you didn't do. I'm not assigning it. Yes, ma'am.
So we didn't have to put like K.
You can if you wanted to. I just basically gave you the symbols, but you can. You need the front lights off because I know it's a little hard to see the way it is. Yes, no, you can see it better. Okay. You know, if I could charge a toll, I could be wealthy. Not just
Try
you,
not to come in
I know.
here.
I'm just giving you a hard time because I don't
No, I
bother
hate
you.
it.
I know. I couldn't resist. Are we getting them right?
Yes.
Okay. This is usually the page no one has a question about.
I just made like-
Huh?
I just made enough.
Okay,
Like, actually wrong.
okay. But you understand what you did wrong?
Yeah.
Okay.
Doesn't matter if you're off by.
Which one?
I think that this third semester.
That should be 20. Mm-hmm. Because you would have said 39 minus 19. Because you've got a mass of 39, you subtract the 19, and that's how you get the 20. It could be you're like Eileen and you subtract it wrong,
Probably.
but anybody have a question on anything on that page before I put the other one up? No? Okay. Now, on this one, before you all ask me a bunch of weird questions, you know, when I'm writing down the answers, I'm not really thinking about sticking it up here for people to look at, but I have found over the years, sometimes it's easier than y'all asking me 400 times to repeat questions. So I didn't have a document camera for a really long time. So I had to deal with repeating answers 400 times. But now I have one of these handy dandy little things, so I don't have to repeat myself 800 times. Now, But that means that when I wrote the answers down, and see how I wrote 23 with a little E minus? People go, Ms. Wall, do I have to put E minus behind the number? The answer is no, you don't, okay? That's just so I knew when I was calling out the answer that was the number of electrons, okay? As long as you know that you've got the number of electrons, protons, and neutrons right, I don't care if you wrote the symbols behind it, before it, or what. You what?
I'll go one.
You added wrong?
Yeah, I think because I was in a rush, I was really tired.
Didn't occur to use a calculator?
No, I was really tired.
Okay.
So I literally, I had this on my bed and I was.
Just filling it in, so if I checked, you had work.
Oh, no, like, I did it. I just.
Okay. Questions on anything up there that you've done other than Eileen just added wrong because she was tired? Anything about the process that's bothering you that you don't understand before you should see it in a short while? Yes, ma'am.
Question 7.
Question 7, okay?
Yeah, I don't know if it's because I was tired last night.
It is entirely possible. It's running rapid.
I put +7, I don't know why.
Okay.
So, yeah, gotta get help.
Okay. Does everybody have that done so I can take it down? Or do I need to wait?
Oh,
Y'all get it checked and then I'll pull the smartboard back up.
Oh, never mind.
What, Cameron?
Go ahead.
Let's take it down. Anybody need more time with the answers? No, I can take it down. Angelin, you got it?
Yeah, I figured out.
You what?
I just figured out like how you got the +2 over there.
Okay. All right. All right, stupid. All right, so if we look at question number 7, you had 30 protons, 35 neutrons, and 28 electrons. So when you go to write this, what tells us the element, Isabel? Uh-huh.
The protons.
The protons. So we know when we look at the protons that we have what element off the periodic table? Z. So we write Z in, and we know that the atomic number is 30. All right, what tells us the mass? Protons and neutrons. So we take the 30 plus the 35, and we get 65. So we know that's the 65, right? Now, in terms of figuring out if we have a plus or a minus over here, what two particles do we check? Are they equal? No. What's the difference between the two of them? Okay, so since the protons are more, we know it's going to be positive. All right, and what's the difference between the two of them? That's how we get a 2. Okay?
I probably was just tired.
You probably were. All right, Cameron. I guess, if you want to. Write your name down.
2 I took a nap yesterday and I woke up feeling Tuesday, so I actually got ready.
All right. Anything else on the homework you want to ask about? Everybody's good. You saw anything on the homework on the quiz today you feel completely confident?
Is this what the quiz is on?
Oh, I don't know what to do.
Okay. All right, let's talk test and then we'll do the quiz.
How many questions?
We get a quiz.
I don't know, about 10. It's pretty typical. Alexis. All right, I'll give you a minute to look at that. Now, just like I told first period, I have historically given test corrections on the first test, and I will do that again this semester so that you can correct this test. You do not get test corrections on every test, so don't think, oh, I'm not going to do this one, I'll wait on another one. I typically choose no more than 2 per quarter. Sometimes I do not do 2 in a quarter. This may be the one and only one you get test corrections on. Yes, ma'am.
Do you have to have a specific grade?
No, you do not.
So-
You can take your 89 and come in and correct it, yes. Okay? Sometimes I do qualify it with a grade and say that if you have an 85 or higher, you cannot do test corrections, which means those people who have that lower grade can only correct up to, they would not be able to surpass that grade.
I had a teacher like that. She said you had a 69 or above, and I had a 70, and she was
Usually I will do something that's in the middle B range. I don't usually do 69 and above.
Just mostly whatever you do. Because I got like a 90 on every test. Not ever.
No, on the first one, I typically let everyone. I've already had someone with a 96 do test corrections during third lunch and raise hers to 98.
So, your points leave it.
Half. So you have an 89, so half of 11 is what, 5.5? So 6 points. Now, that's mitigated on the fact that you correct them correctly. If it's a math problem, you have to show the work done correctly. If it's a logic question, you have to explain how you do it right. If it's just a definition question, clearly there's not a lot you can do except tell me the definition. If you don't know how to do it correctly, you can ask me. I'll be glad to help you work it correctly. You can use me, you can use your notes, you can use a classmate. We're doing it Wednesday, Thursday, and next Monday. That's 3 different days of the week. You may use third lunch if you have third lunch. If you have second lunch, I am sincerely sorry. I have a fairly large crowd of physical science students. They are rambunctious. I'm not going to lie to you. They just are. They cannot deal with the distractions of a group of people coming in and out of the room during third or during second lunch. I've had groups where you would be able to move in and out of the room and it would not be a problem. This one just can't deal. And I'm sorry about that, they just can't. If you came, you would understand. And probably be like, dear God, this fault, how do you do it? But they just can't do it. Okay, so, and I could offer you in the morning, but the times I get here vary anytime from 4:45 to 8:05. So it tends to swing that wide area. So if you're here and you want to swing by, you can, but I'm not making any promises that I'm here. I need you to do me in the courtyard though, if you want to, if you're in the cafeteria and want to chat. Is there anyone who has a question? If it's dying to know the how to ask. Derived means it comes from something else. So typically a derived unit would be one that comes from a formula because it comes from another unit.
You talked about scientific units, and you said that
Scientific notation or significant digits?
significant digits, sorry.
Okay, that's fine.
And you said that you could either round it up or keep it as it is. So,
What's the better answer choice out of those 4?
the one that's right. The one that's, okay.
Overall, I thought the tests were very good. No one failed in this particular class. I can't say that in first period, so I was pleased. I know not all of you are, which is why I'm allowing test corrections on the first one. The next three will not. Typically, if I'm going to allow test corrections on another one, it's on the benchmark. I have a form. It's the same one as Thornhill and Bowers's. We've been using the same one for years. Yes. Uh-huh. Which one is it?
Oh. It says, what metal absorbs 38.7 joules of heat if the mass is
Did you
fixed?
tell me the number? Which one, 43? Okay, I'm there now. You're gonna solve for CP. You're gonna solve for CP using your Q formula. Because they gave you J, they gave you Q.
That's what I did.
Let me see your works.
Oh, wow, I'm supposed to be for that circuit. My work's really messy.
Oh, no, what I did.
Just off the top of my head, I'm gonna guess it's a calculator error.
This whole set of vocab stuff,
That was 38.7, and that's become 8.7. Did you leave the 3 off in front of it? That's my guess, but it's strictly a guess. Anybody else have a question? Yes.
45.
You gotta find the density of all 4 samples, and then which one's gonna go to the bottom, the one that's most dense or least dense? You go to the bottom, one that's most dense or least dense? Most. So the one that's the most dense is sample 4, because its density is 6. So 4 will sink to the bottom. So the density has to be A. Now, if you have other questions, you are welcome to come do test corrections, and we can talk about them all day long, okay? Now, if you will, let me have your test papers back. Those are the only things you don't ever get to keep. I keep test papers. All right? And make sure that you're yes. When you do test corrections, she comes back so that you can read it for 90 days. There's no limit on this particular test. Thank you, sir.
Protons and neutrons always equal mass.
Protons and neutrons always equal mass. That is correct. Now, if you would be ever so kind, you need a writing utensil, a calculator, and a periodic table. And do not be like Tasha and tell me I told you to clear your desk and do not get out a periodic table. You need a periodic table. Actually, right now. All right, does everybody have a periodic table? I got my absentee one, right? I gave you one. You got one? Okay. Now, since you were not here Friday, are you ready to take it? Okay. Cameron, same question. Are you prepared to take it?
Yes.
Okay. There's one for passion here. Okay. All right, put your names on and answer the questions, please. And when you're done, just flip them over. You're still working. Okay, just checking. What about now? People still working, or are we all done? I've entered everything I had to grade. Finished? Oh, a day's still working, okay. Okay, everybody done now? All right, pass your papers to the front. All right, if you will, keep out your periodic tables, but then find the rest of your stuff, because we're going to be using them the rest of the day. I'll have these for you tomorrow. They were as good as first period, so they'll be great. All right. Let's talk about isotopes, average atomic mass, and mole conversions today. And mole conversions is where I ran out of time. First period, because this stupid board was not behaving like it was supposed to. For some reason I cannot explain. You're going to need your periodic tables today, so don't put them up. All right, let's see here. Yep, yep. Yeah, okay. All right. So, anybody talked about isotopes in another science class before? Yeah. Anybody remember what it is? Tell me what? Look over there. Probably so. All right. An isotope is an element with the same number of protons, but a different number of neutrons. Okay? Now, some books don't use that same definition. They use two more technical words based on what we've done the last couple days. So, what is the other word we've learned for number of protons? Yep. So, some books will say an element with the same atomic number instead of saying number of protons. And instead of saying a different number of neutrons, they will say, what's the other technical word we could use instead of saying a different number of neutrons? A different neutrons is combined in what number? Neutrons is found in what number? Atomic mass. Okay? So, it depends on the author of the definition and the book that's being used at the moment as to whether they say same protons and different neutrons, or whether they say it has the same atomic number, different atomic mass. Now, there's lots of examples you can use to talk about isotopes. One that most of you are probably familiar with is carbon-12 and carbon-14. All right, what's carbon-12? Is it what? Probably. I'm not sure exactly what foods, but probably. I'm thinking of something that's a little more obvious that y'all are using right now, or a lot of you are. Yes, it's probably in gas. No. What are y'all writing with? Yes. All right, carbon-12 is graphite. All right, so I'm going to use that infamous word. Now, Miss Wall is going to be 48 next month, which means I was born in late 1969. I would be willing to bet you the vast majority of you, if not every person in this room's parents, are younger than I am. Now, we took lead out of pencils in the early 70s, which means I was a toddler the last time lead was in pencils, which means most of your parents, and you certainly have never written with a lead pencil. Your parents probably never held or used a lead pencil in their lifetime. Okay. He might have at some point had a lead pencil in his hand. Okay? I might have at some point had a lead pencil in my hand. The rest of y'all and the rest of y'all's parents never had a lead pencil in y'all's hands. It's carbon. Y'all are writing with carbon. Okay, it's a carbon pencil. It's not a lead pencil. Hasn't been since the early 70s. Okay, Eileen's dad and myself are the only people that y'all probably know, other than your grandparents, who had the access to a lead pencil. Okay, I don't know if I still have it over here. I had it at some point. I've moved it. I don't know where I stuck it. All right, but carbon's just a piece of rock. We put it in little slivers to stick in your pencil. Lead is toxic. If I get pissed at Brandon and whoop. What about to pull that? Oh well. What? This is why when I go to the staff meeting, Miss Curry's yelling at us about the headphones. People like you have them in your ears, so when she comes in the door, I don't see them up here. She's back there in the door going, why Brandon got his headphones in his ears in the walls class?
For real?
Yeah, for real. Because I'm just pissed. Because this is not the first time we've had this conversation, is it? That's the best you got is Now, carbon is just a rock. It's found in pencils. Okay? Now, what's carbon 14 found in? Let's hope not. Really? What? No.
Wait.
Pens.
No. I'm thinking earth science, maybe y'all talk about it. What? Yes. Fossils. All right. Forget the fuels. All right. Fossils or perhaps carbon dating. This one is radioactive, which is why I said I hoped it wasn't in foods. All right, because it's radioactive, it has a half-life, meaning it decays over time at a steady rate. So we can figure out how old the bones are, maybe from a dinosaur or from a rock, or perhaps something really old that was left in the earth thousands or even millions of years ago. We can figure out how old it was. Now, they're both the element of carbon, but do they behave the same way and have the same properties? No. So they're two different isotopes of the same element. Now, if you look them up on the periodic table, carbon 12 and carbon 14 will both have an atomic number of what? What's their atomic number? Their atomic number will be what? You got a periodic table in front of y'all. I don't expect y'all to have these numbers memorized. You've only been in here day 11. 6. Remember what I told y'all? Memorizing the periodic table is stupid. So look it up. I don't expect anybody to memorize that stuff. So it's 6. So how many protons would carbon 12 have?
6.
And how many protons would carbon 14 have? 6. How many electrons would it have? So how many electrons would this would have? Now, the neutrons is where they're different. So carbon 12 would have 12 minus 6, and carbon 14 would have 14 minus 6, which is 8. So their neutrons are not going to be the same. There we go. Where their protons are going to be the same. Okay? That's what makes them an isotope. Now, the question becomes, what mass are we going to put on the periodic table? Are we going to put a 12? Or are we going to put a 14 on the periodic table? Okay? Which one is going to go on the periodic table? All right. If you look at the periodic table, it has a 12 on there, but does it just say 12? So where's the 0.011 come from? It comes from averaging. All right? Does everybody have the one off the board? Because I actually have this typed out, so you don't have to read my terrible handwriting. Now I got to wait on you after you were playing with your hair. It's like being at home. yet. I should have stayed in bed this morning. The board wouldn't work first period. He's listening to his music over here. You're playing with your hair. Mm-hmm. Not JROTC, are you? Brandon, that's a good thing. All right, so average atomic mass is the average of the isotopes based on its percent abundance. All right, so some isotopes on Earth exist in greater abundance than others. So just thinking about what you know about carbon, which one is going to be on Earth with a greater abundance than the other? Carbon 12 or carbon 14? Carbon 12. There's a lot more graphite on the Earth than there is radioactive carbon 14. Okay? Now, to find the average, I put a formula on the board so we can calculate average atomic mass, because you're going to have to calculate this. Postpone cross country for us. What are the odds they did it for West? All right, so have you gotten to the formula? Look at the end of the formula. What does the plus with a dot, dot, dot mean? It continues. So, how many parentheses did I put in the formula that I typed on the board? 3. So that's for like 3 isotopes. So if we were doing the one that I've been talking about with carbon, I would only need how many parentheses? 2, because I've only been talking about carbon 12 and carbon 14, right? So if I had an isotope that had 3, or an element that had 3 isotopes, I would need 3 sets of parentheses. If I had one that had 4 isotopes, I would need how many sets of parentheses? 4. Or 5, I'd need 5 sets. Okay, that's what the plus dot, dot, dot means. Everybody with me on that? Okay, so as a sample on how to work that, let's do oxygen, okay? And I'll give you a minute to write down your sample. Can you function without your headphones? Okay, try. Let's see if we can manage the rest of class without music playing right here. That way you can hear me. Okay?
Have you ever had anybody question class?
You mean 100? No. We can try.
You get 100 on everything. Oh. Well, 105. Who's your first law? His client. I had Chloe. She was walking on.
$60 is passing it today. All right, we caught up? All right, so how many isotopes do I have? All right, so I need 3 sets of parentheses, right? All right, so divided by 100. That's your basic formula. So for the most part, these kinds are just plug and chug. So what's the mass of the first isotope? Yep, 15.995 times what is its natural percent abundance here on the Earth? 99.759. All right, so most of the Earth on the planet is oxygen 16. The oxygen that we breathe, 99% of it is oxygen 16. However, that's not the only oxygen that's on the planet. There are 2 other isotopes of oxygen, so that's why the mass of oxygen on the periodic table is not strictly 16 with no decimal places. So, if you take the 16.995, which is the next isotope, and multiply by the percent of 0.037, and then the last isotope, the 17.999, which is oxygen 18, times 0.204, we're going to get something pretty close to 16 because they're not a very high percentage on the planet, but those isotopes do change it. Now, notice that the parentheses add together. So when you're doing this, what do you have to make sure you use in your calculator? You got to use your parentheses keys. Let me check because it's a lot of numbers to punch in, so I might have gotten it wrong. Do you make it 16.05?
I got 15.
All right.
I got 15.999.
Then I probably punched it in wrong. 15.99. All right. So looks like I have 2 significant digits as my least. All right, there. But given everything else has 5, 5, and 3, I'm going to leave it that way because we got a lot of decimal places. And I don't want to round it to 2 and just have 15 there. All right, now, a new unit for us. We haven't done one of these. The unit that we're going to use for atomic mass is AMU. You're going to love what it abbreviates for. It stands for Atomic Mass Unit. And scientists decided AMU was too long, so they abbreviated it. So if you don't want to write AMU and you want to use the abbreviation, you can choose to use U. Okay? They abbreviated AMU all the way down to U if you decide that AMU is just too long for you and you want to use the abbreviation. Okay? Why they decided that, I have no idea. But they did. Okay? So, any questions about how to do average atomic mass? Everybody feel fairly proficient with that formula? No, it won't. No. Typically, though, it's usually going to be like in a set of ordered pairs if it's not in a chart. So the percentage is always going to be given with the mass, though. So it's not going to be in some weird separation where you're not going to be able to figure out what the percent is with the mass. No. Oh, gotcha. No. The percent will be on the end of the number if it's not in a table. So you will know that that percent number is with that mass. Yes. Okay. Anae asked, would the numbers always be in a chart like this? And I said, no, it will not always be in a chart. If it's not, it will usually be in a set of ordered pairs, and you will always have a percent behind it if it's not in a chart so that you know that's a percent natural abundance. Everybody okay with that? Feel okay with this, or do we need to practice another one? Okay. Here, do chlorine. All right, this is naturally occurring chlorine. Chlorine, there's 2 very common isotopes of chlorine on the planet, chlorine-37 and chlorine-35. And they're not very rare. There's quite a bit of both of them on the planet. So calculate that one real quick. I think I remember this one from first period because we did this one. My picture in USA Today came up with hurricane damage. Okay, got the damage to up. I think the pictures to work right. That's pre-damage. This does not work right. Go with 4. Biggest thing is I don't want you to round it off too much or you don't have your decimal places so you know you did this work right. I can't see that instruction that way. All right, what'd you get? 35.45?
Yes.
Okay, I think I was talking about first period. And you put what unit behind it? AMU? Sounds great. Okay. All right, in that case, let us talk about the mole. Okay, let's try this one. This one should be, I think, the same file that I need. No. Seem to be on the same pace. I was hoping I'd be further. Oh, I must just be moving slower today. Probably because I don't want to be here. All right, so let's talk mole conversions. The biggest thing is I need to get through 3 sample problems. I only got through 2 in their class. We can get through 3 to work out. And then that's the third one. So, mole conversions. This is probably one of the most important topics that we will do this semester. And we'll do it again in a few days after we do naming of compounds when we get a little more sophisticated, because this topic is going to perpetuate itself through the entire semester, which is why it's so important. It's also the reason that we learn the factor label method, because it's the way that I teach everything all the way through the course. Okay? It's the way all of the math is done all semester long is in moles. So it's pretty important. First of all, what is a mole? All right. Moles are basically units to convert grams to atoms, which is what we're going to learn how to do today. As we branch out, we will be able to go from grams to molecules and grams to formula units. We will be able to go from grams of one compound to grams of a different compound. We're just not there yet. Okay? Now, a mole is equal to exactly 12 grams of carbon 12. Now, it is the basis for the periodic table. All right, carbon-12 is the basis for the periodic table. So, if I was to say, this is just an example. You're never going to have to do this with any other elements. I'm just giving you an example to explain. If I say that hydrogen's mass is 1/12 that of carbon 12. Think math class. What is 1/12 of carbon 12? It's 1/12 of 12. 1. Okay? If you look on the periodic table, what is hydrogen's mass? 1. We can do that with all of the elements on the periodic table. They're all related to carbon 12 in some way. We are not going to do that. Okay? I'm just telling you that all of the elements on the periodic table are based on carbon 12. Okay? Now, our focus today is how we're going to use the mole, and what we're going to use the mole to do is a vehicle through the semester. Okay? That's where we're going with it. Now, you're going to have to work with me on my cheesy example. Okay? Now, my cheesy example on what we're going to do with the mole is going to use eggs. And you're going to have to just hang tight for a second. If I sent you to the store and I told you to get a dozen small eggs, how many would you come back with? Okay. If I sent you to the store and I told you to bring me 1 dozen medium eggs, how many would you come back with? Okay. And if I sent you to the store and I told you to bring me 1 dozen large eggs, how many would you come back with? 12. Now, you've been conditioned from a very young age to know that a dozen is how many? 12. Now, I need to condition you in a chemistry class that, change that, 1 mole of carbon, any kind of element, all right, is equal to 6.022 times 10 to the 23rd. Okay, that's the number of atoms you have. 6.022 times 10 to the 23rd. It's not 12 to be a mole. It's a different number, but it's the same concept. So, if I say 1 mole of sulfur, and I say how many atoms are in 1 mole, you guys now say to me, there are how many? Exactly. And if I do it one more time like we did over here, if I say 1 mole of arsenic, there are how many atoms of arsenic? Same thing. Okay? Do you see where I'm going and see the similarities here? Okay? It's just like a dozen, except the number's different. The amount doesn't change. It's just a gigantic number instead of being 12. It's just a new number we have to learn. Now, were the size of the eggs the same? No, the egg size was different, right? We could go in, we could get a small egg, we could get a medium egg, we could get a large egg. Most of us probably get a large egg because it's not that much more money and we get bigger eggs, right? Now, are the moles going to have the same size over here for their atoms? Yes or no? No. So how are we going to know the mass of each of those moles? The atomic what? You're so close. The atomic mass. So where are we going to find that at? All right, so what is the mass of 1 mole of carbon?
12.01.
12.01 grams. All right, so what is the mass of 1 mole of sulfur?
32.07.
All right, 32.07 grams. All right, and for arsenic, look at number 33.
74.92.
Okay? Now, tell me this. Why are the masses different? Why are the masses different? Why don't all those atoms weigh the same thing? No. Getting very warm though. Pastor, what do you think?
Pardon the interruption, I need Angela and Pomari in the front office,
Okay.
along with John Snyder. Thank you.
You're welcome. Go ahead. Y'all can share it. Each of you put one arm in one sleeve, each. What do you think, Patrick? I know you know. I think you have a suspicion, but you're so quiet you won't tell me. If you had to choose a reason, what would it be if I made you tell me? What? What's what?
Moth is on your hands.
It's a what?
Moth.
Get away.
Oh.
No.
No, that's bad.
It's on the board now.
But the moth that is terrified Eileen is dead. But you didn't get a little moth juice on your hands, your dust. Yes.
Wash your hands, huh?
What? Okay, different number of neutrons. Can you give me a little more? You're almost there. Pastor, could you add a little more to her answer? Nope. Cameron?
No. What did she even say?
She said, I asked, why are the masses different here, here, and here? And Kayla has half of it.
What'd you say?
She said she had a different number of neutrons, and Brandon's got the other half.
Proton.
There you go. All right. There are a different number of protons and neutrons in every one of those. You have the same number of atoms, but each atom has a different number of protons and neutrons inside of each of the atoms, which is what's causing them to have different masses. Okay? Does that make sense? Sort of like when you look at the eggs. Do they all have the same size yolks?
No.
No. The smaller eggs have smaller yolks. The bigger eggs have bigger yolks, right? So those are going to have different sizes or different amounts of protons and neutrons. Now, you know what was causing my board not to work this morning? That moth was stuck in that top corner, breaking the beam so the 4 beams wouldn't line up. Or at least that's what the tech guy thinks. So not that I wanted to mess up your pants, but I was fearful he was going to get that board again and not let my board work tomorrow morning. It was seriously messing with my first period mojo. All right, so everybody okay?
The moth's not.
All right, so what 2 conversion factors do we get out of this? First of all, we can convert from grams, we can go to moles. Okay, from moles, we can go to atoms. Now, notice the direction that I've drawn the arrows. They can go either way.
Can I have Isabel Campos to the main office?
Yes. No, you ain't got one. Just wander up there. Tell them they already took the pass. 2 other people already have it going in this curry. Now, if we start in grams, the only thing a gram can go to is a what? to a mole. Some of you won't want to use this because you'll be fine without it. Some of you will want this. So if we start in grams, we can only go to a mole. If we start in atoms, the only thing an atom can go to is a what? A mole. Well, what happens if you're in moles? You had to write period. Of course, they've already taken 3 people here in the last 2 minutes, so, take a few more. I've only got 12, so take a few more.
For a brief second, a name and passion.
I got moths flying out, scaring people to death. Got people being called out. Now you want people? Just take who you want, Miss Burton. I don't want to teach today. It's okay, Miss Burton. I want to go home. So if you're in moles, what can you do? Go either direction. Okay? Now, what 2 conversion factors did we just talk about? All right. 1 mole can equal 6.022 times 10 to the 23rd atoms. Okay? And 1 mole can equal the atomic mass in grams. Okay? These are the 2 conversion factors we're getting ready to use, and that's our flow chart. Okay?
So they are the what?
Those are the 2 conversion factors that we're getting ready to use. These 2 conversion factors, and then that little flow chart at the top. Okay?
Hey, everyone's back.
Yeah, call somebody else in a minute. Y'all didn't wear the vest? I'm disappointed. All right. Y'all could have done something like the 3-legged race and had a reminiscent day from middle school, elementary school. All right, everybody caught up? All right, so here's a sample. You don't write what's in purple. Only write what's below the blue line. You already have what's in purple. Just write the question below the blue line. How many moles of phosphorus are there in 23.69 grams? How many moles of phosphorus are there in 23.69 grams?
We don't need to know what did they last year.
Don't know yet. Let's set up the chart and then we'll decide. Some questions will require you to use the periodic table. Some questions you might not need the periodic table. It depends on what you put in your chart. Oh, that's good. You found the best that's missing. Fabulous. That would be great because it's been missing. That's why I said you can't take it. Yeah, when the custodian comes, they'll sweep it away. Do you need me to get rid of his carcass or something? Oh, well, the tissues are gone. I got to get a new box. Oh, you have a tissue? Okay, I mean, it wasn't really bothering me, but okay. Sort of like the wolf spider I stepped on this morning in the garage. I just left him there and...
Spider?
Yeah. I just stepped on him and left him. I have to get the... Now, I this is getting ridiculous.
Sorry, I have a fear of bugs. Yes.
All gone. All right, so we're going to do this just like we did everything else. Draw a T-chart. When we drew a T-chart, what do we do? Hold on. What was the first step after the T-chart? Y'all jump to step 3 and 4. Yeah, we write down what we're given on the top line, right? So what are we given? Yeah, that's important. We need to put it on the top line before we start talking about what we don't want and do want. All right, so what don't we want? So now we put it on the bottom line. That's good. Now, this is why I said some of you won't need the flow chart. If you're in grams, what's the only thing you can go to? Some of you will look here and be like, oh, I need moles. So you'll just go, oh, I'm putting moles on the top line. It's completely cool. Now, these are the 2 conversion factors we wrote down just a minute ago, right? Now, which one has both moles and grams in it? The one on the top or the one on the bottom? So that's the one we're going to use. What's in front of moles right here? So we're putting a 1 in front of moles. What is in front of grams right here? So we're putting atomic mass right here. Where do we find atomic mass? On the periodic table. So what element do we have in the question? So what do we put right here?
15, 30, I mean, it says
There we go. 30.97 because we want the mass, not the atomic number. And that's an easy mistake to make to pick up the atomic number. So 23.69 divided by 30.97 and you get 0.764. Nice. Now, why did I put 4 numbers in my answer? That's how many significant digits I have in the problem. I only look at my given data. That's what they gave me. That's what I use. We don't use what's on the periodic table because I put 4 numbers. Some of y'all might have wrote 30.9. Maybe somebody just wrote 31. You always use what's in the given data.
So significant digits are basically
Exactly. Yes. Exactly. All right. Next question. How many atoms of sodium are there in 6.87 moles? We got to do this one more. Quick. Check the new ones. How many atoms of sodium are there in 6.87 moles?
Pardon the interruption. I need the following students to the main office: Yesenia Cruz de la Sancha, Leslie Cruz de la Sancha, Derek Dearman, Destiny Dickerson, Isabel Frank, Nakia Friday, Teresa Gonzalez Castilla, Mackenzie Harvin, Gray Hedrick, Alexander Holt, Sailor Hucks.
All right, so we have moles.
Jayla Jackson.
What goes on the bottom?
Kelly, Karen Kelly Rajan, Darla Coy, Karen Lim, Sheena Loom, Maya Lockhart.
So if I'm in the middle, where am I going?
And Maja McIntosh.
I could go this way, or I could go that way, right? So if I could go either direction, which direction should I go? What does it ask me for in the question? So I'm putting atoms on the top line. Okay? Now, look at the conversion factors. Which one does it want this time? The top one. What's in front of moles? Again, we're putting a 1 right in front of moles. What's in front of atoms? That's what we're putting in front of atoms. So, 6.87 times 6.022, second EE23. I get 4.13 times 10 to the 24th. So what you got, Brandon? What'd you get? What'd you get?
I was just playing.
Oh, you were just playing? Oh. Well, I put the wrong one up there this morning, so I was counting on you. Questions?
This is not a science.
What's this question?
Okay, I moved here last year. Like, first semester. My baby.
Okay.
I didn't get what this was.
You're right. I have no idea how to answer that question.
Yeah.
That is not in what I would know. All right. Last question we're going to do. All right. Last question we're going to do. How many grams of nickel are there in 4.98 times 10 to the 24th atoms? I'm going to hand something out while y'all are writing it. Now, this is the one that creates issues because this is the one that's going to be a 3-step chart. And we have not done a 3-step chart yet. I'm just telling you, because sometimes I don't give it to y'all. All right, so what's our given data?
4
Times 10 to the 24th atoms, right? So what goes on the bottom? What can we go to from an atom? Now, if the question asks me for moles, I'm done. Did it ask me for moles? So this is the new step. Draw another section. What goes on the bottom? Now, from moles, I go to what? Now I go to grams. Now, because I have two sections in there, I'm going to use both conversions. I just got to put them in the right spots. This one is moles to atoms. The top one. What's beside moles?
1.
What's beside atoms? Now, this one is going to have what beside it?
1.
And what's going beside grams? What? Atomic mass. And I have nickel. So when I look up nickel up there, I have what? 58.69. Now, I'm not going to worry about calculating it because we're low on time. For homework, find the paper I just handed you. Find all the way down that first left column where it says problems. All right, you're doing 1 through 7, B's only. So 1B, 2B, 3B, 4B, 5B, 6B, 7B. You know, last night's homework that has a chart on the front, and on the back it said average atomic mass. You're doing 1, 3, and 5. You're doing the odds. Okay? It looks like, for those of you who don't know, looks like this. Okay? On the back side, it's got this on it. Looks like this. It's from last night.
I said do all of it?
Just the odds. 1, 3, and 5. Just to practice. Average atomic mass. You're doing the odds. Okay? Remember, if you want to do test corrections, I will be here Wednesday and Thursday
Devontae
this week.
Pittman, please come to the main office. Devontae Pittman.